Hi and welcome to Math Pre-Calculus 20, Section 7.4, Reciprocal Functions, Example 1. Alright, so we kind of have the idea of what a reciprocal is. Alright, so if we have a number 5, right, its reciprocal is 1 over 5. So that same concept here applies to reciprocal functions. Alright, so we want to graph y equals x, and we want to graph its reciprocal, which is y equals 1 over x. And we'll do it by using a table of values this time anyways, and maybe we'll find out a way that we can do it other times. So first, y equals x. Right, do we need a table of values for that? Probably not. We should know that, right? It's like y equals 1x plus 0. Right, so it has a y-intercept of 0 and a slope of 1. Right, so we can graph that one pretty easily. If you weren't confident on that, right, table of values, feel free. Okay, so we get something like that. Okay, if we had the table of values, right, it would look like x, y, right, so x is 0, y is 0, x is 1, y is 1, 2, 2, 3, 3, everything like that. Okay, this other one, y equals 1 over x. So for this, let's use a table of values. So if we have x and we have y, so say x is 0. Well, it's going to be 1 over 0, which, well, we should realize that's undefined. Right, so that point doesn't exist on this graph. Okay, right, if we see this here, right, that's a non-permissible value. Right, 0 can't be the value for x. Okay, other values, 1 over 1 is 1. 2, well, it'll be 1 over 2, so a half. 3 is 1 over 3. Right, if we went to like 10, it's going to be 1/10. Okay, what if we try some negatives? Well, if we go -1, it'll be 1 over -1, so -1. -2 is -1/2. -5, -1/5. Right, so we should see definitely some trends there. Okay, so putting this on the graph, the point 0, well, we can't use, so we have the point 1, 1, right, which is there. We have the point 2 1/2, so that's like there. 2 1/3, 4 1/4. Oh, we didn't have that one, but it would be 10 1/10. Okay, then we have these other ones here. -1 has a value of -1. -2 is -1/2. -5 is -1/5, right, something like that. Okay, so we're seeing, right, something like this here. What about going up over here? Well, what if x was 1/2? So if x was 1/2, y would be 1 divided by 1/2, which turns out to be 2. So if x is 1/2, y would be 2. If we did the same thing for like x is 1/4, well, that'd be 4, right? And we're going to get this same sort of trend happening here. If we do it with the negatives, right, we're also going to get that same, I kind of missed it there, same sort of trend there, right? It's kind of hard to draw perfectly. But so we can see that we get a graph something like that. So the red one there represents the reciprocal of y equals x, which is y equals 1 over x. Okay, and so there's some really important information that we can get from that graph there. So we're going to explore it a little bit here. So it says at the bottom, how are the two graphs related? Well, the main relationship, right, would be this point and this point. So the point 1, 1 and the point -1, -1 are the same, right? Those are the main things that are related between them. Right, there's other relations here that we're definitely going to look at closer to. So if we turn the page, right, we've got this chart here, and we want to look at answering these. So if I look at the graph there, so y equals x, the domain for y equals x, well, domain, right, remember, is our x values. Are there any x values that y equals x doesn't appear on? Well, no, y equals x, right, goes from the bottom all the way to the top, keeps going forever, so the domain for that is x, is all real numbers. What about the domain for this other one? Well, remember, we looked at our values here, and we found this one here didn't exist. Everything else should exist, so it'll be right? X cannot equal 0. X is an element of the real numbers. Okay, that might be a little bit hard to see. I can go to that page on its own after too. Okay, so it's everything except for 0. Okay, what about the range? Well, again, the range for the first one, right, is everything. Range for the second one, well, if we look at this here, if we think about this line here, as it keeps going, is it ever going to touch 0? Well, no, even if it's like 1 million, it's going to be 1 divided by 1 million, so it's never going to touch 0. This here shouldn't touch 0 either, so the range for that one should be y cannot equal 0. Y is an element of the reals. Okay, end behavior. That's asking, okay, what happens at each end of this graph? Well, what happens as we go this way? What happens when x gets bigger? Well, as x gets bigger, y gets close to 0. So as x increases, y, I'm putting an arrow, y approaches 0. So that arrow means approaches. Doesn't mean it actually touches, it means it approaches. What about, oh sorry, that's the wrong graph. I got ahead of myself there. For the main graph, right, as x increases, y increases. Right, so x increases and y increases. And also, if x decreases, y decreases. I don't have space for that, but if we go this way, right, as x decreases, y decreases. Okay, so now for the other one. We were saying that at this point here, right, as x increases, y approaches 0. Right, so y gets close to 0 but never touches it. Right, as x decreases, well, what happens there? Right, same thing. Y again approaches 0 but doesn't quite get to 0. They come at it from opposite sides though. The top one comes down, bottom one comes up. Okay, the next part. What about the behavior at 0? Well, what happens for this line at 0? Well, it's just y equals 0. That one works. This other one, well, this line here, right, never gets touched. So there, we could say it's undefined. So it's undefined there. And basically it's an area where the graph, again, becomes closer and closer and closer to, but never quite touches. So that is the concept of a vertical asymptote, which we're going to define right after this example. Okay, and then we've got this term here of invariant points. Invariant points are these points here that we noted. So they're the points that stay the same on both graphs. So the reciprocal graph and the non-reciprocal graph. Right, so those are those points there. So we might want to jot that down. So invariant points, so they're the same on original and the reciprocal function. So in this case, those points were -1 and -1, and 1 and 1. Right, and it's not always going to be that. It's going to be close to that, though. Okay, so if you need to look at this more closely, there you go. Right, so the domain for these ones, right here, they're not equal to 0, not equal to 0, but all other values it exists on. These ones, as x increases, y approaches 0. As x decreases, y approaches 0. And then we have this concept of invariant points. Okay, so that is a bit of an intro into reciprocal functions, and now we can kind of take those ideas and apply them to other graphs, and we won't maybe have to look at them quite as closely as we did for that one. Okay, thank you for watching.